SQL injection. You've probably heard the term, and it sounds pretty technical, right? Well, it's a hacking technique that's been around for literally decades, and yet it's still one of the most dangerous threats out there on the web. So today, we're going to tear it apart and see exactly how it works, piece by piece. Let's get into it.
So let me ask you this. Can a single character, just one little quote mark, take down an entire website? It sounds kind of crazy, but the answer is a resounding yes. A single, cleverly placed character is all an attacker needs to completely bypass security and walk away with all your data, and we're about to see exactly how. All right, let's start with the classic example, the one everyone talks about. This is the kind of hack you can pull off in less time than it takes to make a cup of coffee. We're talking about waltzing right through a login form without even needing a password.
Okay, so normally when you type in your username and password, the server sends a little message, a SQL query, to its database. It's basically asking a question. Hey, database, can you find me a user where the name is exactly this and the password is exactly that? If it gets a yes back, you're in. Simple enough.
But here's where it all goes wrong. The attacker doesn't just type in a name. They type in something like this: administrator dash dash. Now that single quote and those two little dashes, they don't look like much, but they are about to completely change the meaning of that question the server is asking.
That double dash, that's the secret weapon. In the SQL language, that's a comment. It tells the database, hey, from this point on, just ignore everything, pretend it doesn't exist. And just like that, the entire password check gets wiped out. The query is no longer asking about a username and a password, it's just asking, hey, does a user named administrator exist? The database says, yep, and boom, the attacker is logged in as the admin. No password necessary.
So that's the how, but the why is so much more important. Why does this even work in the first place? Well, the whole hack is only possible because of a really basic, fundamental mistake in how the application was built.
And this brings us right to the textbook definition. SQL injection is all about tricking an application into running commands it was never supposed to. See, the attacker isn't really breaking in. They're cleverly feeding the application instructions that make it break itself from the inside out.
This right here is the heart of the problem. You have to think of it like this. An application should always treat user input as just data. Plain, simple, harmless information. But with this vulnerability, the application gets confused. It takes that data from the user and mistakenly treats it as executable code. When your data becomes code, the attacker gets to rewrite the rules.
And trust me, bypassing a login screen, that is just scratching the surface. A skilled attacker has a whole bag of tricks, a whole toolkit of different SQL injection techniques they can use to do some serious damage.
We can basically group these attacks into three main styles. You've got in-band, which is the loud and obvious one where the attacker sees the results directly. Then there's blind, which is super stealthy and forces the attacker to be a detective. And finally, second order, which is like planting a ticking time bomb in the database to go off later.
So let's talk about those loud methods. A union attack is wild. The attacker can basically stitch the contents of a secret table, like your user table with all the passwords, right onto the results of a normal search. All of a sudden, the page that's supposed to show you cat pictures is also showing you every user's private info. Or they can use an error-based attack, where they intentionally break the database just to see what secrets it spills in the error message.
Now, blind SQL injection. This is where things get really sneaky. The attacker can't see anything directly, so instead they have to ask the database a series of yes or no questions. Like, is the first letter of the admin password an A? The page might change just a tiny bit if the answer is yes. Or, even more clever, they can use a time-based attack. They tell the database, hey, if the first letter is A, just wait for 5 seconds. If the website suddenly takes 5 seconds longer to load, they know they've got it right. They just do that over and over to slowly spell out the entire password.
So, why do we care so much? Why is this still considered one of the absolute most critical vulnerabilities out there? Because the damage it can cause is, well, catastrophic. It goes way beyond just one person's account.
A successful attack can mean a total data breach. We're talking passwords, credit card numbers, personal emails, everything. An attacker can change or just delete data, causing absolute chaos. They can log in as anyone they want. They can even crash the entire website. And in the absolute worst-case scenario, they can use the database to take complete control of the server itself. Game over.
Okay, that was a lot of doom and gloom. So here's the good news. Despite how powerful it is, SQL injection is almost 100% preventable. The defenses are out there, they're standard, and they work incredibly well.
This slide right here shows you everything you need to know. On the left, that's the wrong way. The code is just smashing the user's input directly into the command. It's mixing code and data, and that's the recipe for disaster. But on the right, you see the right way, parameterized queries. You send the command to the database first, with a little placeholder. Then, you send the user's input separately. You're telling the database, hey, this is the instruction, and this other thing is just data. Never ever confuse the two. That one simple change makes this whole attack impossible.
So number one, without a doubt, is using those parameterized queries. It's the gold standard. But you also want a defense-in-depth approach. That means also using things like stored procedures correctly, validating that user input looks the way you expect it to, and, this is a big one, applying the principle of least privilege. That just means your app's database account should only have the bare minimum permissions it needs. That way, even if an attacker gets in, the damage they can do is seriously limited.
And on top of all that, you can add another layer of security, a web application firewall or a WAF. Think of a WAF like a security guard standing at the front door. It inspects all the traffic coming into your site, and if it sees anything that looks like a known attack, like those single quotes and double dashes, it blocks it before it can even get to your application.
So we have a really clear problem, and we have a really clear solution. Which of course brings up the obvious question. Why is SQL injection still one of the most common attacks we see today?
And the data doesn't lie. Year after year, the security experts at OWASP publish their top 10 list of the most critical risks. And every single time, injection flaws are right up there near the top. It's this stubborn, persistent problem that just won't seem to go away.
And that's really the final thought to leave you with. If we know exactly how to prevent it, why is it still everywhere? Well, the answer isn't technical. It's human. It's because of legacy code that's too old and fragile to fix. It's developers who are never trained in secure coding, and sometimes it's just business pressure to ship new features faster than securing old ones. The threat isn't still here because we don't know how to stop it. It's here because, for a lot of reasons, we just don't.